Hey guys, welcome to another episode of Initial DIY Mods. So pretty much the biggest update right now, I do have a little bit of a backlog of videos, but why I've been gone for the last month or so is that we just moved to Los Angeles, California. So we finally joined the LA crowd, we've left Ohio. We did bring the Mini Cooper with us, the Genesis with us, and of course, if you follow us on Instagram, we brought a new Mini Cooper with us as well that my wife got, so it's an automatic one. So that's sort of the daily while the other two projects are still being wrapped up. So hope you guys enjoy the video. This is us doing all the wiring for it. Getting the 4G63 running has been a challenge, but as you saw, it does start. We did take it on a few test drives. That'll be somewhat of the next video. And of course, we've done a lot of other modifications as well to help the reliability of it. The last real difficult step is the tuning, but of course, to get all that done, here's how we did all the wiring. Enjoy. Alright, so I'm working on the wiring, and basically I've got the fuel injector loom already built over there, and this is the spark plug loom that I've been working on. So basically what we've got our 4-wire spark plug. This is coil-on plug. So basically we've got a power wire. This is going to give it 12 volts and I think 30 amps, something like that. Constantly, and then our constant ground. So we've gone ahead and daisy chained all of those together. And then we have a trigger wire here, and this trigger wire is basically what the ECU is going to send a signal to. That is going to choose that spark plug to go ahead and fire. So we've got that one. Over here it is this one. Over here it is, I think, the purple one. Over here it's the gray one. And then eventually we'll go ahead and loom all this together and get it all nice looking, and that'll be installed in the car, hopefully somewhat stealthily. So for the most part, we've got a combination of heat shrink and electrical tape. Heat shrink where we can fit it, and electrical tape in the places that we can't, just to make sure we don't have any short circuits going across our wiring loom. Now these red ones here, these are all going to be feedback wiring. Apparently that's used more on the OEM side of things. For aftermarket ECUs, they don't really need this. I thought it was a trigger wire positive and then a ground, but looks like we can just chop off these red wires really short and make sure to insulate them so they don't ground out on anything. Basically that's it, and then we'll have these run into the cabin on their own separate wiring, which is what all this is for, to run into the cabin. And over to our ECU, which we don't 100% know where we're mounting yet, but we'll figure it out later. Alright, so we just basically traced out our Mitsubishi spark plug cover and onto some sheet aluminum, and we're just drilling out our holes to fit our spark plugs. And then from there, we can go ahead and figure out where we're going to bolt our spark plugs to, where we're going to drill our holes, and we can't really capture nuts on this because it is aluminum, so we can't like weld the nut onto it. But we'll figure something out for that. Here we go. And now our coil-on plug fits perfectly, and we have to figure out how we're going to bolt it and how we're going to have our wires mounted. So obviously we can't go that way because it goes off of the piece here, but we can go backwards, we can go at an angle, kind of figure out what looks best, probably just going straight back though. We got all the rest of the coil packs out from the packaging, and we went ahead and built our loom, which doesn't look the prettiest, but again, I'm definitely more of a functional person, and I think that the engine in the car, who cares about the loom? Alright, so I've got all these wired up. The red wire is going to be our triggers for the coil packs, and they're written down here. We've got spark trigger for cylinder 2, spark trigger for cylinder 3, etc., etc. And then these are our injector grounds, 1, 2, 3, and 4. A lot of these green wires coming up here, these are our trigger wires for key on switch. The fuse box does not have anything that's key on switch right now, so we're using this relay, this 30 amp relay, to trigger the coil on plugs, to trigger the switched This is the cam angle sensor and crank angle sensor positive, which needs to come on with the key. And then this is the power for the trigger to trigger the relay. And then that relay currently is actually wired up for the injectors through the resistor pack. So not sure if it's going to work too well with the 3 different things running off this, but each one of those components doesn't pull that much current, so 30 amps should be plenty. I do have a 40 amp relay that I can put in there, and then use a 30 amp relay for the fans that are on the radiator. Currently I have that wired partially where I've got it grounded out here, and then this is just for a power wire, and I'll have to run that to a relay later on. I used the ground strap and relocated it to here. Back there it couldn't reach anywhere. And this is my makeshift short bolt. So right here is where the OEM wiring harness actually runs in to the Mini Cooper chassis. So they got those ports there kind of pre-ready, and then you just cut them off and shove your wiring in them, get your access. So we'll probably do that instead of cutting new holes. We'll use what they have set up there. This needs to run to the alternator, but the alternator used to be here on the Mini Cooper, which actually was over here, and now it's way the hell over there. So obviously can't really go front here, aside from it being too short. Exhaust manifold, turbo, all that stuff is in the way. So we need to figure out how to extend in the best routing for this. We might actually go down low and see if we can bring it underneath and actually tie it to this lower radiator support bar. But the main concern with that is if we do bottom out and hit anything, that's going to sever or potentially rip off our alternator wire. So I might want to bring it up a little higher and then come over here and go straight up into the alternator right there. We still need to TIG weld in our bung for the intake air temperature sensor. Currently we just have it hooked up here so we can test it and make sure that it's working and reading on the ECU. But yeah, we're basically going to take where this plate used to be TIG welded, we're going to drill that out, weld this fitting in, and then thread into it, and that way it's going to get our intake air temperature, which allows us to convert what was originally a MAF censored car to a speed density car, which uses the MAP pressure, the manifold absolute pressure, in combination with the temperature sensor to figure out the amount of air going in via the density, and then that allows it to calculate how much fuel you actually need for the car. What we have basically right now coming in the back here, all of our wiring ties in through here. We've got it cut. We are going to remove this plastic later on and then put slice a hose and use a hose around that edge to help make sure that none of those wires get severed or rubbed through. We have our resistor pack back here for the injectors, which are low impedance. And then our wiring comes back through here, comes behind the battery, and they go in here where the factory loom goes through. So right down here in the passenger footwell is where all the wires come out. Right now, of course, it looks like a mess, but we're going to see if we can get our ECU kind of tucked up under there, and then we'll just run a USB to it when we need to do our tuning. So we pulled off the alternator, got the tensioner just kind of swiveled up out of the way, and we need to get this other one on. And it's not exactly a direct swap, so this does need to be modified. It's actually from a Saturn, and on top of that, this alternator's been rewound up to 250 amps. The stock GSX one puts out about 60 or 70 amps, which is not going to be enough by any means. The electric power steering and everything else, it's not going to work. So we got this, and we got a little harness for it, pigtail, to control it, but I don't even know how much we really need that. We have to just hook up a couple wires. We're going to set it up nice and simple. So this one has a fan on it, so hopefully it'll keep it cooler. And then it does have a 5-teeth pulley, and we have a 4-tooth pulley. So, and this is also like a underdrive pulley that helps spin it up a little faster. So apparently that's not going to cause an issue. If you have the right tension on it, it'll still be able to turn that, which in theory, yeah, that's right, it should. All right, so we chopped up the old manifold heat shielding from our Mini Cooper. So the turbo manifold, since we're not using it and we sold the engine, I figured it's basically trash, so we kind of chopped it up, and then we actually ended up folding over since it's a double layer steel with some insulation. I have no idea if it's asbestos insulation or what, so hopefully it's not. But some sort of insulation in between, and then that's going to help keep not only these coolant lines from being right next to the hot side, but the alternator's right here. And there are two issues with the DSM alternator. One is that the power steering pump on the OEM sits above it somewhere, and basically if it leaks, it drips down, so that's one thing. And the other thing is the people that tend to modify their car remove the heat shielding, but it's right next to the alternator, which also tends to kind of burn it out a little bit as it overheats. So got rid of all that, and we got our custom brackets, so let's get everything set up. And basically what we ended up doing is we had to get our belt, which we had to special order from Napa. This is actually a shorter belt. The stock belt is a 39.6, but with the GM alternator off the Saturn, that's the 250 amp one that we needed, you can see there's not a lot of clearance between the oil cooler and the alternator. And the 39.6 would basically hit that, and it still didn't have enough tension on it. So we basically got a shorter turnbuckle, and then this is the ground wire that we have installed to help with the ground from the alternator ground to the chassis ground. It does ground through the engine, but this also kind of helps bring it over to the chassis, especially since a lot of like the electronics and stuff do ground out on the frame, so that does help a bit. We will add some more engine grounds and transmission grounds later. Currently we have this transmission ground, which is the Mini Cooper stock one to the GSX, and then we've added this one, but we're going to have more. We've got another ground up here that ties into some stuff, so we'll add a couple more grounds to help tie everything together electrically. And then this basically turnbuckles is reverse threaded, so we are able to adjust our tension just by turning it. So super simple, but again, really good key feature if we do need to change it out. You can see that it is a tight clearance here. We couldn't get that bolt off originally, so we did chop it off. Then we threaded the back end of that shaft, screwed it back in because we couldn't get it off because of the frame rail being so close. So that's why we ended up chopping it. Just threaded it, put it back in, and then added that coupler nut right there, and then we were able to put in our turnbuckle and then just put a little bolt in there. But we do have to take the water pump pulley off, which is a little bit annoying because, again, there is not a lot of space here to work with. But it's perfect. We've got about 1 millimeter of clearance there. And since it's all part of the same assembly, that should not collide for any reason. But if it does, we can always shave down the head of that bolt. Hook into USB. I'm going to go ahead and open last project. Not connected. You need to connect. Reading. Am I connected? Alright, my inlet air temp is 419. Coolant temp 419. Alright, so something's wrong with my inlet air temperature sensor. Let me see if I can use a... Oh, throttle position's not working. Am I connected? My map needs to be rescaled. Coolant temp I haven't hooked up yet, so that makes sense that it's maxed out. What doesn't make sense is inlet air temp is hooked up. Calibrate TPS. Injector 1, injector 2, injector 3, injector 4. I hear them triggering, but spark channel 2 is a little bit softer than some of the other spark. So injectors and coil packs are working, so that's a positive. Throttle position's not working, and I'm not 100% sure why. I'll have to check the wiring on that. So right now our issue is throttle position and inlet air temp. Neither of those are working, so we're going to go ahead and unplug and go through that wiring and see if there's any issues with how we wired it, if it's incorrect or just needs to be modified. So, alright, so what we're trying to figure out now, we're in the car. We're trying to see if we can get the starter to trigger without the ECU. And we're going to try the simple thing first, which is just plug it in. That was it. Which means we can use the OEM wiring and just splice into it for the new, whoops, don't do that, stop. It kept trying to start. So we're just going to splice in the OEM wiring with our new harness and basically it's gonna one wire connect to the new starter off the GSX, which is an older car, and then it'll start, which is awesome. I don't need the OEM ECU in to trigger the starter. There's no safeguards, so that window doesn't work. So it's set right now to key on, so as soon as that key comes on, this thing will activate. It clears like perfectly, but as soon as that engine starts moving when you're driving around, it's too perfect. So as soon as that thing moves, it's gonna hit. So we gotta clearance it a little bit more, but the hood closes and the latches hold. Not sure what I'm gonna do about the grill part here, but the front bumper fits. So little by little, getting the finishing touches on it, and then we can actually drive this thing. All right, so figure out what was going on. And basically, we need to go up to Tools and Calibrate Thermistor. Yeah, Thermistor tables. Just a weird way to write it out. And we need to go down and select a common sensor. So, in this case, we're going to our air temp sensor. And originally, this was set to select a common sensor. And what we have to do is go down to GM, since we're using the GM sensor. And then we're going to go ahead and pick our units. In my case, I'm going to use Fahrenheit because I'm a bit more comfortable with where those numbers should sit in my head quickly, versus Celsius takes me a second. We're going to write that to controller. Alright, so there we go. You saw the needle jump. Go down here to close, and you can see that 45 degrees is what's going on here, which is pretty good. I've got the heater in the garage here. Cranking away over there. I've got the floodlight back here, so we're warming up the garage slightly. But again, it's also like 15 degrees outside or 28 degrees outside. It's been 15 for the last week. I think it's like 30 now, which is still pretty warm, but I'm from Florida and that shit's cold. So Coolant Temp, that's still not hooked up yet. I have a spare sensor. I'll see if I can use the common sensor from the 4G63 originally, which is there. If not, so I go back to Thermistor tables, coolant temperature, so 3-point therm generator, common sensor. So they've got GM, Ford, Mazda, they've got Mitsubishi. So maybe I can use the Mitsubishi tables, and when I get that hooked in, I'll be able to get it figured out. So I'll write that to controller now, and then that way when I hook it up later, I'll know immediately if it's working or not. Ugh, excuse me. And thank you for everyone that said bless you to the screen. Yeah, we're going to see if we can figure out what's going on with the throttle position sensor. It might be, I did damage the ECU a bit, so I'm going to have to either fix that or get a new one because I ripped a wire out and it shredded the board, which sucks. But throttle position is still not registering, at least with the wires hooked up. So that could be a voltage issue, that could be the TPS issue, but I think that should be fine because I tested it before and it was working on the other car. It could be that it's not configured properly in the table, similar to how this one was. So we're going to just dig around and see what we can figure out. Alright, so we got our laptop in the car. We're going to plug in our ECU here in a second. It's down there. So basically we found a wire that was broken inside of the ECU. It was like, as soon as you turned it to put it in the case, it basically disconnected and the crank sensor wasn't reading. Alright, so we're finally getting our fan set up here. So we've got it hooked up into the ECU, which obviously is a pretty big cluster right now. Big rat's nest. Hopefully we'll get some ECU connectors that we can just make one giant connector once we finalize the wiring as to where everything goes. And then we can connect the two, solder everything on the giant connector, and then have one thing that snaps in, snaps out, and not have to worry about undoing 30 wires every time we take it in or out. So to check what we got here, so currently the coolant temp's 160, the engine is off, but the car key is on, so this should work. And we can test it right now. So if we turn the car off, the thing should ground if it's always got power. So it doesn't always have power, which is good. And then we can turn on the car. And then now we do 155, let's say, since that's below the coolant temp. And our fans just kicked on, if you can hear it. We can come back here and say 171, and our fans turn off. So that's working now, so we got that set up, and we'll have to just finalize the wiring for it, and then that's it.